Okay, what we have proved actually is that any compact connected surface without boundary is homeomorphic to one of the following. So the two-sphere, the connected sum of G tori, or the connected sum of K projective planes. Right. So the plane model here is just A inverse. If it is the connected sum of G tori, then it looks like A inverse, B inverse. And if there are G of them, then it's going to be repeated like A, B, A inverse, B inverse. Maybe this is number 1, this is number G. Or the connected sum of K projective planes, right? So which means that it looks like C, C1, C1, C2, C2, and so on, CK, CK. So notice that here, the I don't know, C1, C1, C2, C2, the connected sum of two projective planes, so the connected sum of two projective planes is actually homeomorphic to the Klein bottle. That's a tutorial exercise. And in this Klein bottle, it has this nice visual representation. Now, there is an alternative version that we are also going to do as a tutorial exercise that goes like this. Slightly different version. So instead of doing this, so we can prove that any compact connected surface without boundary is homeomorphic to either a two-sphere with G handles, so G may be 0, right? So what does it mean? So if we have a sphere looks like this. So what is a handle? So a handle is basically, it looks like this. So first handle, second handle, and so on. But then, of course, a sphere with, say, 2 handles. Then let me draw a sphere with 2 handles. So that's the first handle. This is the second handle. This is our sphere. This is, of course, it is the same thing as the connected sum of 2 tori, right? So sometimes it is kind of convenient to think of them as the connected sum of tori, sometimes as a sphere with handles, but it's the same thing, right? So in this theorem, items 1 and 2 correspond to item 1 in the second version. So, and the connected sum of K projective planes. So this can be thought of if there is an odd number of them, that this can be thought of as the projective plane with handles. And if there is an even number of them, it will be a Klein bottle with handles. And again, so the second alternative version is going to be a tutorial exercise. Okay, now I hope that this is clear. So we maybe let me wrap up the lecture a little bit. So in this lecture, we have seen what topology is about. And the central notion here is homeomorphism. This is kind of what topology stays on. It's basically everything in topology is up to a homeomorphism. And we have proved this amazing theorem of classification of surfaces, that every surface is homeomorphic to the two-sphere connected sum of 2 tori, or the connected sum of projective planes. We have not finished it in the sense that we haven't proved that these different items in this list are not homeomorphic, that the connected sum of tori is not homeomorphic to a sphere or the connected sum of projective planes. We are going to do it later in lecture 4. Yeah, and this is the short concept check that we are going to work on in our tutorial again. And then after the tutorial, I hope that everything is going to be nice and clear. Okay, thank you very much.